Hey, so today we're going to talk about ionic bonding and how to name ionic compounds and write formulas for ionic compounds. All right, so what exactly happens when an ionic compound forms? Electrons are transferred, and it's between a metal and a non-metal. And we're talking about binary ionic compounds, with binary meaning two elements. So metals, they tend to lose electrons. The reason being, if you look at on the left, a lithium atom here it's in group 2A, or it's in group 1A, so it has one valence electron, and it needs 8 to be stable. What makes more sense for lithium to give up that electron to a nonmetal or to take 7 in? It's going to do whatever requires less energy. So it's going to give up that one valence electron, and when it does, its first energy level that has 2 electrons in it, that's going to be full because the first energy level only has to have 2. It'll be stable if it gives up that 1 electron. And if we look at the chlorine atom on the right, it has in its outermost level, its third energy level, it's got 7 electrons. Remember, it's in group 7A or 17, and it is going to take in an electron to have 8, and it can get that electron from lithium. All right, and they both want to become stable. They want their outermost energy levels to be full. So, metals, since they have a low number of valence electrons, they tend to give up electrons. Non-metals, they have usually 5 or more valence electrons. They take them in, and this is what happens when they move there. They're gonna form ions. So lithium loses this 1 electron. It's going to have 3 protons and only 2 electrons. So it's going to have a +1 charge when it loses that electron. It's no longer going to be a neutral atom. It's going to be an ion. This chlorine, when it gains an electron, it's going to have 18 total electrons instead of 17 protons. So it's going to have a extra negative charge. It's going to form a -1 ion. So metals like lithium form positive ions. Non-metals like chlorine form negative ions. They're called anions, and the positive ions are called cations. So, and once they get them close together, if you notice, lithium gives up that 1 electron, and then its first energy level becomes its valence shell, and then it's full, it's satisfied. Chlorine gains that 1 electron in its third energy level, which satisfies its octet, and they form ions. Lithium forms a plus, which is a +1. If there's not a 1 there, it's understood, or a 1 positive, whichever way you want to say it. Chlorine forms a negative or a -1 or a 1 minus, and those difference in charges causes the opposites attract. That causes them to attract and bind together to form a compound. Lithium chloride is formed. Now, since it's one thing about ionic compounds, the charges have to balance one another. You have a +1 and -1; they balance out. It only takes 1 atom of each to form this compound. The formula would be LiCl. All right. If we look at another one, if we look at sodium chloride, sodium is in group 1A, it has 1 valence electron. Chlorine has 7. When they get the close, sodium loses that 1 electron, and it forms a +1 ion. Chlorine forms a -1 ion. They bind together the opposite charges, and you have a neutral compound. Compounds have a neutral charge, a 0 charge. All right, if we look at one though, like this is magnesium and chlorine. If they're going to bond, magnesium in the middle there has got 2 valence electrons in group 2A. It needs to lose those 2 electrons. Chlorine is in group 7A or 17. It has 7 valence electrons. So as this chlorine gets close to this magnesium, if you notice, magnesium gives up 1 of its valence electrons to the chlorine, but that chlorine is satisfied, but magnesium's not. Magnesium still has 1 valence electron, so where's the electron going to go? Well, it's going to take another chlorine atom to get that other electron. And when that happens, magnesium forms a +2 because it needs to lose those 2 electrons. Each chlorine forms a -1. You add those together, you get a -2. +2 plus -2 equals 0. That's a neutral compound. So the formula, it would take 1 atom of magnesium, 2 atoms of chlorine. The formula would be MgCl2. With a little more calcium and chlorine. Calcium has 2 valence electrons. Chlorine's got 7. It's going to give its first valence electron to this chlorine, but calcium's still not satisfied. It needs to get rid of 1 more. It's going to give it to this chlorine. Calcium forms a +2. The chlorines both form -1s, and the formula would be, it would take 1 atom of calcium, 2 atoms of chlorine. So the formula would be CCl2. Now, if you notice, we write an ion, we write it as a superscript, and it has a charge, a positive or a minus. And it corresponds to the number of electrons given up or the number of electrons taken in. When we write the formula, if you see across the bottom there, that formula CCl2, that subscript 2 means number of atoms. It takes 2 chlorines and 1 calcium to balance out the charge. Now, to go through, you should have already went through and wrote down your notes. We're going to go through this pretty quickly. Ionic compounds are formed when a metal transfers its valence electrons to a non-metal. So those valence electrons are the ones that are important. And again, it's when a metal and a non-metal. Metals lose electrons. We explained why that was just now. And they form positive ions called cations. Remember, cats are positive. Nonmetals gain electrons and form negative ions called anions. That's a negative ion. The force of attraction between the cation and the anion bind the compound together. We said opposites attract. You got a positive and a minus, and they make that compound stay together. The overall charge of any compound is 0. It's neutral. Now, ions, cation, like I said, is positive. Some examples: magnesium forms a +2. You can write it like that, or, there's nothing wrong if it makes to write it like this. That +2 means it needs to give up 2 electrons. If we was writing chlorine, you can write it either as 1 minus, you could write it as -1, you could write it just as a minus. All 3 ways are fine. What that means is chlorine needs 1 electron. It gains an electron and has a -1 charge then, because it has 1 more extra electron than it has protons. Okay, these are what's called polyatomic ions, and we're going to talk about those later on. The anion's a negative ion. The chlorine, it could write as -1. This is a sulfate ion, and we're going to talk about those, like I said, in a couple of days. Alright, so predicting ionic charge is group 1. Now, you remember they have 1 valence electron. They're going to lose that 1 electron and form 1+ ions. Or if you want to, you could say +1 ions. And examples, what happens is hydrogen, even though it can act as a metal, even though it is a non-metal, form a +1, lithium +1, sodium +1, potassium +1. Next, group 2, they lose 2 electrons. They lose their 2 valence electrons to form +2 ions or 2+ ions. And those are some examples right there. Beryllium, magnesium, calcium, strontium, and barium. They all form 2+ ions. They all give up those 2 electrons. Okay. Group 13, they lose 3 electrons to form 3+ ions. This group is also called 3A. Remember that they are a positive 3 or a 3 positive. Everything in that group. And really, just boron mostly don't act. It mostly reacts with just other nonmetals to form covalent compounds. Really, it's just aluminum and gallium. Okay, next group 14. They lose 4 electrons or gain 4 electrons. Neither. They rarely form ions. Now you could say that these are either a positive 4 or a negative 4, but mostly those elements just react with other nonmetals, unless we're talking about tin and chloride, and they form both positive 4s. They're actually transition metals. They can form other ions also, but we'll talk about that later. Now, group 15, or 5A, they gain 3 electrons and form 3 minus ions. So these form 3 minus ions. They're in group 5A, which means they need to be stable. They need 3 electrons. When they get them, they'll form negative 3 ions because they'll have 3 more electrons than protons at that point. All right, so here's some example ones. And one thing about it is once an atom, the nitrogen atom, once it forms an ion, we no longer call it the nitrogen, ion. We call it the nitride ion. We drop the ending when we're talking about the ion. Same thing with phosphorus. It becomes the phosphide ion. And arsenic becomes the arsenide ion. Now, when a nonmetal, like I said, we take the root of it, drop the ending at IDE. Okay, group 16 or 6A, they have 6 valence electrons. They need 2. When they gain them, they're going to form 2 minus or minus 2 ions. And we write those ions, like I said, as a superscript. And that just means that they gain 2 electrons when they form their ion. And the oxygen becomes the oxide ion. Sulfur becomes the sulfide ion. Selenium becomes a selenide ion. And then group 17, they have 7 valence electrons. They need 1. When they gain that from a metal, they form 1 minus ions. And fluorine atom will become the fluoride ion. Chlorine, the chloride ion. Bromine, the bromide ion. Iodine, the iodide ion. Okay, group 18, they do not form ions. Their charge is 0. They do not react with other elements. You will never see, any Cl. If I ask you to name that, and it would not be neon chloride or neon monochloride or anything like that, it does not exist. Now, write these down. If you haven't done so already, stop this video, write these down on your periodic table that you keep in your notebook. This is the one you're going to use on tests and quizzes, and while you do practice problems, go ahead and write these ions down. There's no use in just memorizing this when you can write it down above the groups. Above group 1A, put 1 plus, or 2 plus, or plus 1, however you want to do that. And group 2 or 2A, 2 plus, and then so forth. You're going to need to know these when we're writing formulas for ionic compounds. Now, writing binary ionic compound formulas, we write the chemical symbols for the metal, cation, and the nonmetal, anion. That's the symbols of the elements. And their charges. If you write that down, going back right here, this is their charges. This is also called oxidation number. So if you hear me say oxidation number, I'm referring to that charge that the ion is. Then you're going to check to see if the charges are balanced. If the charge is balanced, cancel them out and write the formula. If they don't balance, cross the charges and write them as subscripts in the formula. Do not include the positive or the negative part of the charge in the formula. We're going to work some examples just in a minute, and that'll make sense. Naming binary ionic compounds, you name the metal, you name the nonmetal, drop the ending and add ID E. They are no prefixes. We use that for covalent compounds. For ionic, we do not use these. Now, what happens when the following metals and nonmetals react? So to show you this example, I'm going to show you a long way of figuring out the formula. All right, if remember we talked about Lewis dot structures. If you have Na, Lewis dot structure, it's in group 1 or 1A, it has one valence electron. Fluorine is in group 7A. It would have 7 valence electrons. So what would happen was sodium would lose its electron. Fluorine would gain that 1 electron. Sodium would form a +1 ion or a 1 positive. Either way, fluorine would form a -1 ion, and then they would form, it would only take 1 atom of each to balance the charge. +1 plus -1 equals 0. So the formula would just be NaF. It would take 1 atom of each to balance the formula. All right, so that 1 atom of each is a ratio because the way the ionic compounds, are usually crystalline solids. So if you have a compound, say red is sodium and blue is fluorine, then you would just have, it would be a 1-to-1 ratio of sodium atoms to fluorine atoms in this crystalline solid. Now let's look at calcium iodine, see if that's any different. So we have calcium. It's in group 2A, so it has 2 valence electrons. I'll just show them like this. In the Lewis structure, iodine is in group 7A. So what happens is this iodine needs 1 electron to be stable, to have an octet. It's going to get that electron from calcium, and when it does, it's going to form a -1 charge, but it's stable now. But calcium's not stable, so what needs to happen? Well, it's going to take another iodine going to take another iodine for calcium needs to lose that other 1 valence electron, and when it does, it forms a +2 ion, and then you have 2 iodine ions. So when we write the formula to balance the charge, 2 plus, -1 plus -1 is -2. 2 plus -2 equals 0, so that's what, a compound is neutral. The compound form would be Ci or CaI2. Now write 2 as a subscript. This right here means it takes 2 atoms of iodine to balance out the calcium atom, and that would be the neutral compound form. That's the formula for it. Remember, we write ions like that as a superscript. It means that it forms a positive. That's the charge. When we talk about subscripts, that's the subscript. It means number of atoms. But calcium iodine, and then when we name this, it says calcium. Name the metal, name the nonmetal, drop the ending at IDE, calcium iodide. Now, every time I write a formula, do I want to go through and draw those Lewis structures? It would take me forever if I had a big worksheet full of problems. And there's an easier way to do these, and that's what we're going to look at. Going back to our rules that we just wrote down. So we're going to write the chemical formula, form from the following ions, and name the compound. If we know what the ions are, first of all, we look back at our chart. We have them written down above our periodic table. I've got them written down for you in the first examples we're going to do, but then you're going to have to figure out these out on your own. So sodium, you would look back, if I didn't have it written down for you, you'd look back at your chart and you would write it in as you'd write +1 or a -1 or excuse me, or a 1 plus, either one, and you would go from there. So if you were just starting and just pretend like you didn't even know these, just those sodium and chlorine were reacting, then I would look up on my periodic table. I'd say that sodium is a 1 plus, chlorine is a 1 minus. If these are the same, if they add up to equal 0, then I can just mark them out and write the formula. This would become NaCl. That's the formula. And then I want to name it. I simply name the metal, which is sodium. I name the non-metal. Cl is chlorine. I drop the ending and add IDE. That becomes sodium chloride. I do not use prefixes. Now this next example, if I have this Mg, it's the magnesium ion and the oxygen ion. Let's just pretend like I didn't even know those yet. Pretend like I just knew I had magnesium and oxygen. I look up my periodic table. Magnesium is in group 2A. I know it's going to form a 2 plus ion, right, as a superscript. Oxygen's in group 6A or 16. It's going to form a 2 minus. Now, if these numbers add up to 0, I'm just going to cancel them out and write the formula. Now, if I add +2 and -2, they equal 0. I would just mark those out. I can either do one or two things. I can mark them out and write the formula, and that becomes MgO. I name the metal magnesium. Name the non-metal, drop the ending at IDE. Oxygen becomes oxide. Now there's one other way I could do this though. If I have magnesium that's a +2 and oxygen that is a -2, I can cross the charges. I can cross them, and then I can bring the 2 down here. Bring the 2 down here. I do not bring the positive or negative down, and then I can, when I write the formula, that's Mg2O2. I can reduce my numbers. 2 and 2. 1 divides into both of them, so that would just be 1 to 1 because it's a ratio. That becomes just MgO. That would be the formula. It only takes 1 atom of each to balance the charges out. Now if we look at our next example, we have the aluminum ion. It's a 3 plus, and the selenium ion, which is a 2 minus. Now, what would probably be easier for you to write, when we rewrite, is, and you can pick whichever way works for you, but I like to write them like this. Al, I look at my periodic table, it's in group 13 or 3A. Above there, I've written down that those are a +3. I like to write it like that. And then I have seleniums in group 6A or 16. Look above the group there, and I've written down that those are -2. If these numbers do not add up to 0, positive 3 plus negative 2 is positive 1. They don't add up to 0. I can't just mark these out and write the formula. But what I can do is cross the numbers. I can bring the 3 down here. I can bring the 2 down here. I do not bring the positive or negative, just the numbers. And I write them as subscripts. That's AL2 SE3. Alright, now what some people want to do is they want to leave this positive 3 here and negative 2 here. That is wrong. Do not do that. You erase those. Or they want to write these numbers here as superscripts 2. They want to write 2 and 3 here. That is wrong. You write them as subscripts. That would be Al2 Se3. That means it takes 2 atoms of chlorine of aluminum, 3 atoms of selenium to form a neutral compound with a charge of 0. Now, that's a lot easier and a lot faster than doing it where you do the Lewis structure and see how many more atoms you need to balance out the charge. So then when I name this, I name the metal first. That's aluminum, my first element. It's always going to be a metal. Name the second element, drop the ending IDE, it's selenium, drop the IUM, becomes selenide. I do not use prefixes. This is not dialuminum triselenide. I use those for covalent compounds. These are ionic. Now my last example, we got potassium, this is K, and the nitrogen ion. So I'm going to just pretend like I didn't even know those ions there, and I can look them up. Look potassium up on my periodic table. I've written above group 1, that's what it's in. Those are always a positive 1. And then I look at nitrogen. I find it on the periodic table, and above group 15 or 5A, I've written down that those ions all form a negative 3 because they need 3 electrons to be stable, and they're going to gain them from a metal. Now, if I add up positive 1 and negative 3, that does not equal 0. That equals negative 2. So I'm going to have to cross my charges. So I bring the 1 down here. And remember, I do not bring the positive down. Can't have, and I bring the 3 down here. I do not bring the negative there because you cannot have negative 3 atoms. Because when I bring the numbers down, they no longer tell me charges, they tell me the number of atoms of each thing that I need. So then I write the formula. That would be K3N. I don't put the 1 there because it's understood that there's only 1 atom of nitrogen. That is forms a neutral compound. Take 3 atoms of potassium, 1 atom of nitrogen to form, I name the metal potassium. I name the non-metal, drop the ending in that IDE, nitrogen becomes nitride. Now what I want you to do is work these examples right here. When you're completely finished, go back to the PowerPoint and check your answers.